In this lesson, we're going to talk about function transformations. We're going to look at how to describe function transformations, and our focus in this video is going to be on translations. So how are we going to approach this? We'll start off by discussing what function transformations are. Then we will explain translations. There are two types of translations, the vertical translation and the horizontal translation. Then we'll also examine a technique for expressing translations. And then we'll do that also in function notation. And then we'll use this knowledge that we have gained so far to answer some examples, to address some questions together. So what is a function transformation? A function transformation just means change. So we're changing it from the parent function to a new function. And so in this case, because we're talking about translations, we're going to be changing this function by translating it. We'll get into what a translation means shortly. So what is a translation? Translation simply means we're sliding the function left or right. So we're going on a slide, we're doing a function slide left or right, or a function slide up or down. So if we have a function that looks like this, let's go with just a basic function. If we have a function, this is a parent function, y equal to x. So if we say that we are going to be sliding it left or right, so we can go this way, or the function can move that way, or we can go up, the function can go up, or the function can go down. When we have vertical translations, it simply means we're moving it up or down, and the reason why we call it a vertical translation is because the function moves on the y-axis, and the y-axis is our vertical axis. With the horizontal translation, we're moving it left or right, which is our x-axis, and the x-axis is your horizontal axis, so any movement on the x-axis is known as your horizontal translation. Now let's go into detail with each of these. Horizontal translations are translations that happen with the input of the function. So that means we're moving the x values left and right. Remember that the x also is your domain. So we're moving the function along the domain. And generally, horizontal transformations generally tend to behave in the opposite way of what we think. For example, if I have f of x and we're moving it, we have a transformation of f of x minus a. This simply means we're going to move a units to the right. I know most will think that because we have negative a, we should be moving to the left, but we're actually going to do the opposite of what you expect, which is when you have a negative, we're going to go to the right. When you have a positive, when you have this expression here, if it's negative, so you have negative a, then you are going to move to the right. If you have plus a here, we're going to move to the left. But now, when we look at this expression, f of x to f of x minus a, we're actually just focusing on the value of a. If a is positive, then we go to the right. But if a is negative, which is going to be something that looks like this, f of x minus, and then we have negative a. Let me write this properly. X minus, and then we have negative a. So you can see that that's why it becomes x plus a. So because we have x minus negative a, this shows here that we're going to do we're doing a translation to the left-hand side. Vertical translations are a lot easier to manage because they work exactly the way they look. So for example, we have f of x plus a. This just simply means that we're going to go up a units, and when this value here is minus, we're going to go down a units. So it's pretty straightforward. Now let's go ahead and do some examples together. So we want to express this transformation in function notation. So here we see that f of x is moved 3 units left. So we're going to remember what we have. We always have f of x minus, it says 3 units to the left, so it's going to be in the negative direction. So this is going to be f of x going to f of x plus 3. Express this transformation in function notation. F of x is moved 5 units down. So it's going to be f of x is moved, so you can see that it doesn't really affect f of x directly in the input variable. Is going to affect the function as a whole. So it's going to be 5 units down is going to be negative 5. So f of x going to f of x minus 5. Express this transformation in function notation. F of x is moved 5 units down and 7 units right. So we have f of, I'm going to put x, we have 7 units right, so minus 7. And then we also go down 5 units, minus 5. So we're going to have f of x, it's been transformed such that we have f of x minus 7, 7 units right, and then 5 units down. Now let's switch it around. Describe the function represented by f of x minus 4. So you can see the transformation is happening in your input. So we're going to have function translates, and we're going to say this is a horizontal translation. It translates horizontally 4 units right. That's what this is going to be. Then this other one, so the function translates, it's a translation, function translates vertically 9 units up. And then the last example, we have a combination here. So we talk about function translates. We're going to have, so you can remember that this has to be minus negative 1. So it translates horizontally left 1 unit and vertically down 3 units. So this is how you can describe transformations and the transformation we're focused on is translation. Translation simply means we're sliding left or right, up or down, and then here we've looked at some examples on how you can look at the function and decide and determine what type of transformation is happening. We've also looked at describing the transformation and then deciding what the function representation of that transformation is.